All right, good evening. It is a Friday. I said I would be on Friday, and the first thing I'm going to do, as always, check to make sure that voice is coming through. It usually is. Just make sure all my settings are right, so I'm not sitting here for 30 minutes going through a live or longer with no voice. And if nobody comes on, I'll never know. Usually if somebody comes on, they'll let me know. It is a Friday. And there they go. I am good to go, which it has been very good lately. All right. Just for giggles, I use, one second, that is a little loud. Let me check one more thing. There's nobody on yet, so. Let's turn it down there. I don't need that. And then let me just check this. Check one more thing. Nobody on yet, so I'll just turn the music down a little bit. I do like having a little bit of background music, so it's not just me. Just check this. And so I'll wait for that to kind of come through. I don't want a whole lot of feedback, so I'll check it again in a second. But tonight, what I'm doing is a test review. This is an off night. Typically, I do Tuesday and Thursday, but as mentioned in class, this is in my own time and it's optional. If you subscribe to the channel, it'll pop up when I'm on if you have a few minutes pop. I'm not sure why I just switched again to my transition. Let's try this again. So I didn't touch anything and it switched. But anyway, tonight I'm doing a test review. As mentioned in class, I do Tuesday and Thursday, typically 7 o'clock in the evening, online office hours. I'm not obliged to do office hours. This is in my own time. And there will be some Tuesdays and Thursdays where I'm unavailable to be on for online office hours. But if I'm not able to be on like I wasn't last night, I try to do a makeup time. This will be the makeup time. As mentioned in class as well, if you're unable to make these, and these are optional, I always leave the video up and I actually post it up on the Moodle. So by the time we get back to our face-to-face portion of the class, it gives you a chance to see what we were working, what the test review was, what some of the problems were. And if you have any questions outside of this that you don't come on and ask here, then you can post them in the Moodle in my little section that is made for discussion questions. And if I ever get an email with a question like the other day, I won't say who it's from, but I'll take the body of it, put it in there, and I'll answer it in there for everybody in case it's a global question and not just for an individual. Excuse me. So without further ado, I want to say one thing before I get into this. Most of you probably aren't streamers, probably aren't concerned with this. I'm always concerned with this when I watch other streamers because I'm curious what their setup is. And so my setup, I use a 2015 iMac. So it's an older iMac. I've maxed it out every which way that I can. It still runs well for me. I could probably use an upgrade, but I still use this and it runs fine. I use Ecamm software, which is much like OBS. It's a shell that I put everything into, and I prep for it like that. I use a Stream Deck to change scenes, although tonight, as you saw a second ago, it switched on its own. I use a Blue Snowball mic. I have up here, in fact, let me see if it'll switch for me now. Of course not. So let me do it manually. There's main, but I don't want main. I want main workspace. Okay, so I have up here, this is Keynote presentation. I just kind of plug my stuff in there that I can work through while you're up here, because if I write it, it's hard to see sometimes. My calculator's TI-84. I work through calculator as well during these streaming times and allow you to maybe run it back, watch it several times, write it down. I will make available to you a cheat sheet that has all the commands so you can get used to it. You can put it on your 3x5 cards for your test if you need to. Of course, during the quizzes, you're not allowed to do that. You're just allowed to use the calculator. But if you ever have calculator questions, as long as it doesn't give away the problem itself that I've given you, then I'll help you with the syntax on the TI-84. This is not a TI-84 class. This is a statistics class, and the TI-84 is just a tool that we use. So, all right. So I think that's all. I actually pushed this, by the way, Ecamm through Restream so that I can restream it to several locations, although right now I'm just pushing it to YouTube. With all that boring stuff out of the way, let's get started, and let me just get off. Let me just double check my phone here. All right. So I think that's all. Yeah, so there we go. So again, I just wanted to note whether the sound was too loud, not too loud, etc. Okay. We're going to run through a test review. So I'm going to start tonight with measures of center. And I'm going to take this same problem, which is one I've used in test past. I usually have a little bit more below it, but I just need the set for this. So I'm going to take this, and one second, let me fix this. I have plenty of time to get my stream going. I had plenty of time to get the stream going, but I was reading through a mathematical tasking book and I got kind of sidetracked. So we are looking here at the number of credits being taken by a sample of 13 full-time college students for a semester. Use sample statistics, not population. So I've told you there exactly what to use. So we're gonna find the measures of center for this particular set. Now at the bottom, my big head negates a little bit of that, but notice for the above problem, use the correct computational formula for variance and show all work below. That's an example of what you'll have on the test next week, just like from the quiz, and I'll walk you through what I mean by that. So for at least one of my problems, you're going to have to walk me through the setup of the variance or standard deviation, maybe the mean, but more likely variance and standard deviation, so I can see that computationally, kinesthetically, as you're writing and putting on paper, you can walk through it and not just use keys on the calculator. All right. So I left myself a little bit of workspace here. Let's first find the easiest of all of them. Let's first find mode. Let's find the mode. Is there anything that occurs more than once? Well, 12 does. And how many times does 12 occur? Looks like just twice. 14 occurs twice. Okay, so I've got 12 and 14 unless something occurs 3 times. I've got 16, 16 and 16 and 16, that's 4 times, so those are gone. 16 trumps. I've got 15, 15 and 15, just 3 15, so that doesn't move out anything. The 16s look like that's it, so there we go. 16 is our mode. Sorry I wrote the extra modes up there. The only reason I did that is because at the moment 12 and 14 were our, it was a multimodal set, looked like. It looked like we had several modes here. So the mode is 16. Okay. Now let's look at the median. And in order to do the median, what I'm going to have to do is put this set in order as I'm working with it on paper and pencil here. So I'm going to put it in order. So I'm going to go from my lowest, and let's change colors here. I'm going to go from 12, and I have 2 of those. So I have 12, 12, then I have 13, just one time. I have 14, 14, so I have 2 of those. I have a 15, 15, 15, so 3 of those. If I remember right, I have 1, 2, 3, 4 16s. So I got 4 16s. And what am I left with? Just the 18. Erase all my scratch marks there. Let me count just to make sure. So I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. 6, 7, 8, 9, 10, 11, 13. No problem. Get my scratch marks off. Okay, we're ready to find median. All of that walkthrough for you just so we can find the median. So let's see what it is. Going to go backwards from each end and find the center. There it is. So this is an odd set, right? Let me count again. 1, 2, 3, 4, 5, 6. 1, 2. Yeah, so there's 13. So 15 is the median. No problem. I'll write that up here. That is the center. And the median is the point. Sometimes it lies in the set, sometimes it doesn't. This is an odd numbered set, so the number actually falls in the set. 50% falls on this side, and 50% of the remaining data falls on that side. That's it. So now I'm going to find the mean of this set. And this one I'm going to actually set up. So I'm going to erase out what I've got here for the mode. Well, I hope this is transmitting okay. I'll look at it in a second. Hopefully it is. I just see a little bit of a glitch up there on the screen, which sometimes is because I've got that background in there. I think I'll be okay. So I'm going to erase all of this out. By the way, if you come into my stream and you're from my class, just let me know you're here. And then if you have any questions, by all means, just type up there that you have a question. If you need to explain it because typing it out is going to be too much, I can bring you in as a guest and we can kind of go back and forth. So there's no problem there. So let's now look at the mean. And the mean I'm going to actually set up. So I'm going to go back down here with a light blue. And this was use sample statistics, not population. So from a setup standpoint, if I'm using sample, then I'm looking at x bar equals the summation of the xi's divided by how many are in the set. Well, we know 13's in the set, right? So I'll remember that. So the summation of the i's just means I add up all the numbers that are in it. So I've got 12 plus 14 plus 16 plus 15 plus dot 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 plus 16 plus 15. So I went 1, 2, 3, 4 in. So I got these numbers in. The dot dot dots are all of these. That's your dot dot dots. And then the 16 and 15 I've got on the end, and then I divide that by 13, whatever that comes out to be. And I'm actually going to go back to the calculator. I'm going to plug those in right here as we're sitting here. And I'll bring that up in a second. We'll use that to find our answer. And so this is the setup. So if the problem on my test, if I ask you in the red below for the problem, use the correct computational formula for variance, show all the work below, which in the case of this one would be use the correct computational formula for mean and show all the work below, then this is what you would show. And then you would go one more step further. Whoops. So I'm going to go stat on here, edit. Give me just 1 second to enter these in. 12, 14, 16, 12, enter, 14, enter, 16, enter, 15, enter. So we got 12, 14, 16, 15, 13, 14, 15, 13, 14, 15, 18, 16, 16. (12, 16, 15). You'll notice me going back over my stuff when I put this stuff in the calculator, especially a small set. Make sure that if I put a number in wrong, it's going to come up wrong, so I don't want that. 15, 16, 12, 16, 16. 16, 12, 16, 16. 18, that's where we're starting at. So we got 18, 15, 14, 13. 18, 15, 14, 13. 15, 16, 14, and 12 should be the last one. Beautiful. I got it all in there as I need it. I'm going to scroll over to L3 at the very top, hit clear, and hit enter. Okay, so now I can scroll, and I've got it all in place. So let me go out of this. Let me scroll over, and here we go. So I've got my calculator up. I've got the numbers there in L1, and what I want to do now is I want to find the sample mean. Several ways to do this. So the first way I'm going to look at it is I'm going to go to the stat key, and is that going to take away my other? I'm going to try it anyway. Okay. So we're going to use this key quite a bit. And we're also going to use the second key that's going to point to the second function of this key, which is list. So we're going to go second list and do this. So our function for finding this is going to be, second stat, scroll to math. Sorry, my handwriting tonight. Scroll over to math. Scroll down to mean. Then second, in this case I've got my data in L1, so second L1, and then enter. Those are the steps we're going to take. So second stat, excuse me, scroll over to math, scroll down to whatever function we're doing. In this case we are finding the mean. So scroll down to mean. It's going to come up mean with an open parenthesis, go second one, and that tells it to find the mean of all the numbers that are stored in L1, then hit enter, and we'll have our mean. So let's back out of this, and let's do that. So I have to exit out of here first, or it's going to try to enter whatever I'm doing into the cell that's selected. So I go second mode, which is quit, and then I go second stat, scroll over to math, and scroll down to mean. There it is, highlighted in pink. Hit enter. Second one. So close parenthesis. Calculator, find the mean of the numbers that I have stored in L1. Hit enter, and I get 14.769. Okay, that seems okay. That seems about right. However, there's another way to do this. And remember, the other night we had a question. We actually had a light bulb moment for students on why we were off by about 2 points on variance in a particular problem. It's because we did population variance within the cells themselves, putting formulas in. When I used the calculation here, it found the sample. So in order to check this, I'm going to go to, that's right, pen. I'm going to go to stat, calc, and I'm going to do one variable statistics of L1. There they are. See, I don't know what, that's not right. Yeah, it is. I'm looking at the wrong number. 14.769. So there we go. 14.769 is the mean here. I have 2 pens, 2 iPads. Is the mean. There it is. That's the same thing we just got. So that's the sample. X bar is the sample mean. And what we found by going into second stat over to math down to mean, L1, second one, was this same number. So we've checked it. We're okay. I feel good about it. All right. So let me scroll back over to here. And let me go back into File and bring up this. Let me do this. Second stat. Mean second L1. 14.77 is what we're going to go with. We're going to round it up. So now it didn't negate all the other stuff off of here, but it's okay. Our mean was 14.77. Okay, I'm good with that. So we just found the mode of this. 16 was the mode. It occurred 4 times. It occurred the most. Nothing occurred more than that or the same amount of time. So we had one mode here. We found the median by putting the numbers in order, counting backwards. This is an odd set. It has 13 in the set, so the number actually was in the set that represented the median. And then we found the mean, and I showed you again back to the red for the above problem. Use the correct computational formula for, it says variance here, but I could easily on the test say mean. Show me the formula, use the dots, work through it. If you have to go back and look at it, please do. If you have questions, I will do another session on Tuesday, so please show up then. I don't think anybody's here tonight. Of course, it is a Friday night. I don't blame you. But it looks like one person's on it. I think I'm out of it in my phone. So if you are from my class, by all means, please let me know in the chat. Let's press forward. with no questions coming out. I tell you what, I'm lagging a little bit, and I don't like this. So I apologize for the video. It's probably going to be a little bit choppy, at least where it comes to me. It's because I got that dynamic background in there that used to run really well. Now all of a sudden doesn't. I'm just complaining. Okay. This screen stayed the same except for one word, variance. So we are going to work with the variance of this same set. I have the set in my calculator, and now I'm going to work with population. So I'm going to work with population variance with this one. So even though it says use sample statistics, not population, we're going to use population here. So let me just scratch that out. So basically use population. All right, number of credits being taken by a sample of 13 full-time college students for a semester. Use population. And we are. So find the variance. So we're going to find the range. That'll be the first thing that we find. I don't like this color. Let's go with this one. So we're going to find the range. The range is nothing more than the largest number, the max, subtract the min. The max in this set is 18. The min is 12. So our range is 18, subtract 12, which equals 6. There's our range, no problem. Range alone doesn't tell us a whole lot, so we're going to move on and find the variance, and then finally we'll find the standard deviation. And I'm going to use the red at the bottom. For the above problem, use the correct computational formula for variance and show all work. So let's jump right in. I'm going to erase the range. Very simple task. And let's find the variance. We are working with population variance. Population variance is lowercase sigma squared equals the summation of the x values, each x value, subtract the mean squared divided by big N. Okay? We're going to write it out here and talk about it. Then I'm going to go back and I'm going to use the calculator. So here's what it looks like written out. And I just work my numbers left to right. As mentioned in class for the last 2 weeks, I always say that I just work left to right. It's the easiest way for me. We read left to right. It's the easiest way for me to do it. If you have a better way of doing it, absolutely. There's no problem with that as long as you include all the numbers. You could arbitrarily select numbers and do it if you wanted to, but there's more room for error if you do that. So I'm just going to start with 12. What was the mean of this? What was the mean of this thing? 14.77. Okay. I'm going to write that at the top so I don't forget it. The mean, I'm going to assume it was a population. So the mean was 14.77. Okay. So I have 12. I'm going to go down here at the bottom. So I have enough room. So I have 12 subtract 14.77 squared divided by 13. That's your first term, plus 14 subtract 14.77, then square it, divided by 13, plus 16 subtract 14.77 squared, divided by 13, plus dot dot dot, plus I'll just go with the last one here because I'm run out of room here. The last one would be 15 subtract 14.77 squared divided by 13. And remember, these three dots just represent the excuse me. Sorry about that. So those dots represent the numbers outside of 16. So from 15 all the way to n. These are our dots right there. Right? I just don't have room to write them. I'm just representing how I did it, what I did here. So now, if you were doing it computationally, you would want to write them out because you would want to work each one individually and find out what the terms were before you take the sum. Don't forget, I know some of you missed that first class, and this was kind of a foreign term to you because we talked about it in the first class, but that is summation. So once you have each one of these terms, you add them all up in the end, and that gives you your variance. Okay, so this would be how you set it up. And I can't emphasize this enough. I leave room on the test. You must show me all of this. You must show me the formula, and you must show me this here. And the only reason I'm underneath there is so I had a little bit more room. Okay, so now let's go to now I'm going to go to my calculator, and here we are. So now I'd like to find the variance, but remember, if I try to find the variance using second stat, like if I go over here and go down to 8, hit enter, and go second 1, which is the numbers that are in this set, I've still got them in here. That gives me 3.03. Okay, so let me type that in over here so I got it, so I don't forget it. 3.03. But that is your sample. And let me show you how we can check that. I can go stat, calc, one variable statistics, enter. I might have to scroll up. This is funky on this one. Notice it doesn't have the variance up here. It just has the sample standard deviation, which if I take the square root of 3.03, I get 1.74, which isn't good enough since I had rounded. So it's not giving it to me here. So anyway, what I'm going to do tonight is I'm going to go back to the table because I like to teach it from the table and talk about the syntax of the calculator along with utilizing the table for understanding. So here's what we're going to do. We're going to put the formula up into the L2 so it will fill in all the way down. Oops. So our formula for variance is the summation of x minus mu squared divided by big N. Okay? So what I have to do is substitute in here for all of this. So what's my x going to be? I need the syntax of the calculator. The calculator needs to read this. So where are my x values? Well, my x values are in L1. So I'm going to have parentheses L1. I'll actually have double parentheses. Subtract the mean what was our mean? So I got to go back out and do it real quick. Second quit, second stat. You won't see it because I've got the screen frozen. Such a simple number that I keep getting. 14.7, 14.77. Okay, 14.77. So the mean was 14.77. Remember in class the other day I showed you can actually just put that formula in here. It just makes it a little bit harder. So I want to keep it simple on here. I don't have a lot of room on my screen tonight. So there's that. And then I'm going to divide by 13, which is how many there were in the set. So L1 subtract 14.77 squared. All of that's inside of another parenthesis so that it doesn't get the order of operations wrong. The calculator will often do that without having enough parentheses. So I'm backing out of here, and now I'm going to put my form in, and you will see it where it says L2 down there, and I've got L2 highlighted. That's where you have to be to put this formula in. Otherwise, it'll give you errors, and you'll sit there for hours trying to debug it, or minutes, however long it takes you. So I'm going to put parenthesis, second L1, subtract 14.77, close parenthesis, the x squared button will give me the square key, or you can hit caret 2, either way. Then I close that, and it all closed, yeah. Then I go divided by 13, I think was our number, and I hit enter. There are our terms. So, in our first term from the previous page, we had 12 subtract 14.77 squared divided by 13. Well, that is 0.59, that is 0.59022, which is highlighted there. If I did the next term, in other words, if you did this 14 here, it would be 14, subtract 14.77 squared, divided by 13, and that term would be 0.04560. There we go. Kind of a funky, it's more like an 8, sorry about that, 0.04560. So that term comes up to that number, and so on and so forth. So we've got all our terms here. All I have to do now is find the sum of them. So I've had to find the sum of that, right? Okay. So actually I didn't need to do that. I can just come out. Okay, so I've got everything in L2, so I'm going to go second quit, second stat, scroll over to math, scroll down to sum. And I'm going to take the sum of L2 because that's where each of my terms is from that variance formula that we've been using. Second L2, enter, 2.7929. 2.7929. Second quit, whoops, second stat, scroll over. What we found earlier was the variance this way, and that gave us the sample variance, which was 3.03, but our actual variance is not 3.03, it's 2.79 because we're working with the population and we're dividing by 13 instead of 12. So there you go. I have worked a couple of problems here, measures of variance. And now the only thing I'm going to say about this, and I have repeated it in class quite often, you will see this on the test, you need to be able to explain this. And I feel like folks were okay with this the other night in class. Oops, variance equals so if you take the square root of the variance, you get the standard deviation. If you square the standard deviation, you get the variance. So the mathematical relationship between those two is simply square root of the variance equals standard deviation. The square of the standard deviation equals the variance. That's it. We've talked about that quite a bit in class, but I wanted to reiterate it real quick. And the last thing I'll say on this page is I will reiterate again, for the above problem, use the correct computational formula for variance and show all work below, even though below is missing because my head's in the way. That's what I expect you to do on the test for at least one of these problems, and I will outline it. Don't skip it because that'll be an X. Understand it this week and ask questions if you need to tonight if anybody comes on, and then next week in Tuesday's open office hours, or on the Moodle if you get froggy this weekend. All right, so the last page of, actually I have a couple of pages, so let's look at this last page of measures. Now we're at measures of position. So let's talk about measures of position real quick. I'm not going to walk through an entire one here because nobody's on right now, but I'll go through a shortened version of it. So basically in class the other night, we were breaking our set up into quartiles. We're breaking it into 4 equal pieces, right? 25%, the next 25%, the next 25, and the last 25. Like breaking up a dollar bill, 25, 50, 75, $1. So we're looking for what we call the 5-number summary that pulls those numbers out. The first number is the min, so that's the lowest one. In this case, that would be 12. The next number is considered Q1. That's your 25% mark. The next is the median, your 50% mark. Q3, your 75%, and then your max. Max in this case, I believe, was it was 18. Was it 18? And the min was 12. The median, gosh, I don't even remember what the median was. So, oh, it was 15, I think. Seconds. Yeah, it's 15. Okay, thought so. So our median was 15. So the median in this case was 15. So let me put these numbers back in order. And I'm trying to write them real small here so that I've got room over here. So I've got 12. I did not have another, yeah, another 12. 12, 12, 13, 14, two 14s, 15, 15, 15. Then I had 4 16s. And then 18. Sorry, that is really crammed together. I do apologize for that. However, that's going to allow me to work through this. So I worked backwards. 1, 2, 2, 2, 2, 2, 2, 2. There's my median. 50% on one side, 50% on the other. Now, if you remember in class, we went through and worked a lot of detail in this. The Q1 is your median of the lower 50%. This is your lower 50%. 1, 2, 3, 4, 5, 6. Got 6 numbers in it. The middle 2 numbers are right here. In between those 2 numbers, or if you took an average of those 2, you would have 13.5. So the median of the lower 50% is 13.5. Hence, Q1, 13.5. On the upper end, this is the upper 50% of data on that side of the median. If you look through right there, those 2 numbers. So on this side, 16 even. And that represents your 75th percentile. That is the 75th, that's your 75 cents out of $1, so to speak, is how I used it the other night. And that is 16. So there we go. We've got the min, the Q1, the median, the Q3, and the max. There it is. We drew a box plot from this, so be prepared to do that. Outside of that, we were very descriptive in what we were doing with the 5 number summaries. That's about it. Okay. With that said, I am going to move on to the last piece here. And let's talk about the empirical rule, which deals with a normal curve. So heights of women have a bell-shaped distribution with a mean of 161 centimeters. Has a standard deviation of 7 centimeters. Using the empirical rule, what is the approximate percentage of women between 154 centimeters and 168, 147 and 175, greater than this, less than that? Let's take a look at it. First of all, what does this curve look like? So I'm going to draw to the best of my ability this normal curve. So I'm going to go probably the best normal curve I've drawn in a long time, although it looks a little bit skewed left. So this is a symmetrical distribution. It's a bell-shaped distribution, a normal. So we're working with empirical rule. We have given to us, I have to use a different color, so let's go real light blue. Does that work? Yeah. So we are given that the mean is 161 and the standard deviation is 7. By the way, in this class, I know it's a 10-week summer class, you got to get used to these symbols. If you remember the first class, I said one of the drawbacks students doing well in this class is that you never learn what mu is, what sigma is, etc. So if I write that, I shouldn't have to go over every subtle nuance of it. You should understand right away that's the population mean, population standard deviation. It's what we're using for this normal curve. All right, soapbox done. So let's go down here, and 161 is right in the middle. One standard deviation away is 161 plus 7. That's 168. On this side, if you subtract, you get what? I don't know, 5, 6, 154. Okay. So I'll leave it right there for the time being. This represents your no standard deviations away from the mean, 1 standard deviation away from the mean, and 1 standard deviation away from the mean. 154 to 168 is right here. How much data or how much area underneath the curve basically is here? Well, with empirical rule, I told you to know these 3 numbers, right? So between 1 and -1, this is 0.68. So if you're looking for the approximate percent, now the question asks for percentage, so certainly you would just write, 68%. It's mighty bright. That's terrible. That's better. 68%. 147. Well, 147 is 1 more standard deviation this way, isn't it? And 175 is 1 more standard deviation this way. So when you're looking at the area between 2 standard deviations on either side, now you are looking at 95%. And then to challenge you, if you go less than 168, what would that be? And if you go greater than 182? Well, let's just stick with the less than 168. So less than 168 would be from here all the way back, and that's all the way back to negative infinity. So all the area under the curve from 1 standard deviation away back. If you remember from the other day, there is, I'm so sorry, I'm running out of room here, but between 0 and 1 standard deviation is half of the 68, so there's 34% there. So all you're adding to the 50 from negative infinity to 0 is 34 more percent. So you're looking at approximately 84%. And that's it. The greater than 182, the reason I'm going to push that one to the side is because I've been on here for about an hour. Nobody's come on yet, and I think I've reached kind of a point on a Friday night where I want to end it. My pictures are getting a little scrubby, and I'd have to redraw this in order to go back over it in a meaningful way. So I will leave it right here. For anybody that came on and watched for a few minutes, thank you. If you come back and watch the video on demand, certainly thank you. Leave a comment and tell me if it's choppy, if it looks okay, if you need any help with anything else. When I go back and review these through the week, I'll take a look at those. If you have any questions you want to put in the Moodle from my face-to-face class, please put those in the Moodle or send me an email and I will place them in the Moodle and answer them. I want to make sure that you are prepared for this first test. Again, the summer term is not a 16-week, it is a truncated 10-week. So we have to kind of move fast through the summer. It's been a good class so far with discussion. Hopefully our assessment scores will be the same way. All right, that's the end of my live. I appreciate anybody that comes back and watches this. I certainly do. If you join the channel, I appreciate that too. I put stuff like this out there every once in a while. Even though I'm an old gamer, I'll put a gaming stuff up there. I doubt it suits anybody's fancy, but it'll be out there. And if you want to join on Xbox sometime, just let me know. I'll be glad to play. We can relate the gaming to mathematics. I like doing that and trying to find the mathematics within the games, especially when it comes to probability and random occurrences. So that's it. Thanks for watching, and I will see my class in class next week, and then next Tuesday I will run another open online office hours. Thanks.